Good morning, everyone. We have today a webinar, and actually we call it workshops, which we dedicate to radios and all aspects related to radio products that we sell. My name is Eugene Aksionov. I am IT director of the company, and I will introduce today our presenter, Matt Johnson. But before I do that, let me tell a couple of words about technical things in this webinar, and probably people will come during this moment and connect to us either. So we have about 25 minutes of presentation today, and then we have question session as usual. You have ability to create questions by question tool, or if you want to ask anything by voice, you also can do it by raising the hand. I will see it and let you talk. All video will be recorded from this workshop, and we will put it on the website as soon as it's ready for public, and you can find it on the website and social media and YouTube either. So now let me introduce Matt Johnson, who is our big friend of the company. He's professional engineer in surveying area from Ohio. We work on projects in close relation, I guess, 7 years or more. He is an outstanding contributor in our Triumph LS product and development process. So please welcome. And he also 5LS member and active member of our support.java.com forum, which you're probably familiar. And so please welcome Matt Johnson.
Hi, everybody. I'm Matt Johnson. I'm going to be doing a radios introduction workshop today. The first thing I want to talk about is just some of the different radios. I get the right slide to come up. Right. These are different radio models. Models are the most popular models we sell. There are 1 watt, 4 watt, and 35 watt radios. So the first one is the HPT 401BT. It's a 1 watt radio with internal battery, UHF radio. All the UHF radios require a license to operate in the United States. And then we have the 4 watt and 35 watt models, which are the HPT 404BT and the HPT 435BT. These both have external batteries. And we have the 2 JL models, which stand for just in length. These are 4 and 35 watt radios. These 2 radios have internet connectivity, so they can be configured through the internet, and they can also broadcast and receive corrections through TCP. So it's kind of a hybrid radio, so it can do both UHF and TCP corrections. And then there's the HPT 901BT, which has an internal battery, 1 watt output, and it's a frequency hopping radio, so it does not require a license to operate in the United States. Next, I want to talk about selecting a location to set up the base station and radio. I think everybody should know this, but ideally your base station should be located in an area with a clear view of the sky, so you can maximize the number of satellites you're seeing. The radio should be located in a high area with a view shed that includes the location of the points you need to survey. The view shed is a geographical area that is visible from a location. Since radio waves do not travel through the ground and have a limited capacity to travel around obstructions, you want the radio to be in an area with a good view shed. The third thing that will help is if you elevate the radio antenna or extend the range of the radio. Ideally, you want the radio to be at least 1 meter high. It'd be even better to have it up 2 meters. Then if you need a longer range or there are terrain obstructions, you can use a repeater to extend the range of the radio. And here, I just want to talk about a couple of different profiles that show radio view sheds. The first example on the left side there, on the left side, these are all good radio reception examples. On the right side, they show poor or no radio reception. So in the first example, you have the rover, which is the LS at the bottom of the hill, and the radio at the top. So there's direct line of sight between the two, so you get good radio reception. Whereas the second example is you have the LS at the bottom of the hill, but the radio is beyond the peak, and there's no view shed between the LS and the radio in the second example, so you might not have radio coverage in that example. In the third example is the same profile, but we add the repeater near the top of the hill, and that way you have line of sight between the radio to the repeater and then to the LS, so you get good radio reception. The fourth example, we have the rover, the LS on one side of the hill and the radio on the other side of the hill. This is an example of where you would not have radio reception. Fifth example is the same profile, but here we have the radio at the bottom of the hill and the LS at the top, so there's line of sight between the two and you have radio reception. The sixth example is the same profile, but here you have the rover at the bottom of the hill and the radio at the top. So again, line of sight between the two and you get reception. The last example, number 7, you have the LS on one side of the hill and the radio on the other side of the hill with a repeater at the top of the hill. So there's line of sight between the radio to the repeater and then to the LS, so you get good radio reception. I want to talk about the way to determine the view shed for a given location. There's a free website, www.heywhatsthat.com, that can be used to determine the view shed for any location you want to check. So just go to that website, and the first thing you need to do is just click on the location on the map where you want to check the view shed. The second parameter, it gives you an option to select the highest point within a given distance. So you can do that by clicking the move button if you want to move to a high point or see where the high point is. And the third option is just to specify the height above the ground. The default value is 6 feet. So if you're using a higher antenna pole for the radio, you can enter that in that box. And you just, the fourth box, you just enter a title and then you submit the request. It's going to take a couple minutes, and then it's going to generate a map that looks like this. The red shaded area shows the view shed. Say where you see the red, you know you should have good radio reception. Once you get again beyond the shaded area, then the radio coverage may start to drop out. Next, I want to talk about some radio range tests that were conducted this month in Armenia by members of the communications team. They found that direct view between the radio and rover is very important. The link quality is poor and down loss occurs when there's not direct view between the radio and rover. With a 1 watt power output, the maximum range was found to be 6.3 miles with an internal antenna and 15.8 miles with an external antenna. With a 4 watt power output, the maximum range was found to be 10.3 miles with an internal antenna and 18 miles with an external antenna. Then they increased the power up to 10 watts, and they were able to get a range of 20 miles before they stopped the test. So that just shows that if you have view between the radio and the rover, you can get quite a lot of range out of the radio. And these are just some photos of the test site. There you can see the Triumph 1 base station in the back with the radio set up beside it. And again, the first picture here shows the radio. And then the next two pictures show them driving down a road and checking the radio reception. Same thing here with these last three photos, just different areas along the road. They're seeing how far out they could go. I want to talk about the UHF status screen and some key parameters to understand about it. This screen can be opened in JField by clicking the UHF icon at the top of the home screen. So first I want to talk about RSSI, which is the relative signal strength indicator. It's the signal strength being received by the radio and the rover. Values below minus 100 dBm are considered poor. Next is the bit error ratio, BER. The number of bit errors is the number of received bits of the radio data that have been altered due to noise, interference, distortion, or bit synchronization errors. If BER is 0, is desirable when the radio is working properly and there's no interference. You should also pay attention to the radio state. When the radio and the rover is working properly, it should display ready, none. Then I want to talk about LQ, the link quality. This is the indication of the quality of data packets being received by the rover. When it drops below 100%, data from the correction stream is being lost and RTK performance suffers. Then there's a latency. This is the delay in time from when the base station receives the GNSS data to the time when the rover receives the correction data. This should be under 1.5 seconds when the correction stream is good and corrections are being received. Then finally, there's a received and lost count displayed at the bottom right corner. It's the number of packets being received and the number of packets being lost. When the correction stream is good, the receive count should be increasing every second without any increase in the number of lost packets. Now I want to talk about a method to test to make sure your radio is operating properly. If you believe the radio is not working properly, it can be evaluated by recording the RSSI values at 100 feet. Bit error values should be 0 in most cases, except if you have a 35 watt output and D16 QAM modulation at 100 feet, you may see some bit error. If the RSSI values are more than 3 dBm lower than the expected values, then either your base or rover radio may not be operating properly and you need further investigation of the issue. And this table just shows the expected values at 100 feet with different power outputs using both the internal and external antenna. So for example, with a 1 watt output, you'd expect to see minus 43 DPM signal strength at 100 feet with the internal antenna, or minus 31 with the external antenna. And we'll publish this information on the website so you can have these values to check to make sure your radios are working properly. And now Eugene is going to talk about the radio promotion offer.
Thank you very much for the beautiful presentation, Matt. Yeah, we have a promotional offer today, and it's actual since this moment when we have this webinar, and will continue until September 1st. The promotion means 25% discount for radio equipment and accessories of radio equipment equipment in the order. So if you place the order right now and put a promotional code, as we mark it as radio 25, see that in the right top corner. So this promotional code will mark this order about the discount, and we will take care about calculation this discount for you, and you will get this order with discounted by this 25%. Okay, so we can go to the question session now, and we have a couple of questions while registration time, and the one is not kind of question, just some from Zach, which is supposed to get more information about setup, range, and advantages, which is covered by the presentation already, I guess. But another one is from John, who is asking what is the best choice, UHF radio or cellular connection via SIM card. It is not exactly related to ultra high frequency equipment, but maybe Matt, you can answer.
Yeah, I can talk about this. So this really depends on how good the cell coverage is and the location you're trying to survey. If you have good cell coverage, like 4 bars of service, then typically the cell connection is going to be the preferred and better method of communications. The delay is going to be smaller and just allows more data to be transmitted. But UHF is used for areas where you don't have good cellular coverage. So really all depends on your cellular coverage.
Okay. The Adam is asking actually about discount for other equipment, and yes, this promotion applies to any radio equipment.
I see Sean had a question too. He says, I thought about testing the RSSI when using the internal antenna of the Triumph LS. The RSSI is somewhat dependent on the orientation of the LS to the base, where the external is not. Yeah, this is true. So when testing the RSSI, you want to have the antenna, which is on the back of the unit, facing towards the radio.
Okay. Another question from Hunter.
I have both a 435 and 401. I like to switch between them and use their different advantages, but I find this to be difficult, if not impossible. Is there an easy way to switch between them? As long as you power only one of them up at a time, I don't think you should have an issue. I'm trying to recall if you can have more than one radio paired to a base station, which I'm not sure of off the top of my head.
I just can comment a little bit that it is not that easy, like switch the button from one modem to another one. But that's a good point to think about development. So we probably need to support these capabilities.
Yeah, in JField, you can definitely create a separate profile for each, which would help. So just with the power output sends and stuff, have a different profile for each. The next question was about the antenna being used by Sean in the range test. I believe they always did use the 5 dB gain antenna with the base station. And he had a comment that the 5 dB gain antenna can also be used with the 4-watt radio. It can be used with the 1-watt radio as well to improve the range.
We had some question also about compatibility of equipment with different vendors. So Matt, maybe you can shed a light on that.
Yeah, so we support ADL compatible radios, which is Trimble. And these would be the Trimmark and TrimTalk protocols. And then it's also compatible with Satel radios.
Sean is asking, do you have any thoughts on the repeater with MSM corrections?
I really didn't prepare anything to discuss about like the different modulations and stuff to be used with repeaters, but you do need to use a higher modulation when you're using a repeater. So typically you probably have to use D16 QAM modulation when you're using a repeater. So when you do use a higher modulation, it's going to reduce the radio range some.
Yeah, Hunter's asking, is there some place that shows what a good setup and configuration is for radios and Triumph LS?
I'm trying to understand if he means like a good location to set up the base of the radio, or the different settings inside J field of how they should be configured.
Yeah, Mr. Edwards could probably make some specific details. Yeah, but settings. Yeah, that's what I meant. He means what is the optimal setup for J field application to have it run.
When we use a 1 Hz frequency output, and then depending on how many satellite systems you're outputting would determine the modulation. It's pretty self-explanatory of the modulation and the configuration when you do base forward setup inside J field. You know, so there's a format box, and then you have RTCM 3.0 and RTCM 3.2. So RTCM 3.0 is just GPS and GLONASS, where you want to use RTCM 3.2 when you have all 4 constellations.
Mr. Edwards is asking about any materials that, like PDF, that explains this all stuff. So I can answer partially on this question, Matt, if you don't mind. We have a lot of documentation on java.com website. It is in publication section. So you can see how to configure devices and read that specific things about the radio either. But Matt did a good work to have this testing session, and probably he will give us more materials to be published on the website, how he was promising to do already.
Oh yeah, that's my intention. So I'll make a PDF of this presentation and then also add some of the things I talked about in the documentation for setting up a radio and that type of stuff.
And always I should mention that if you have any questions about the products or setup, or you have some applications which are not that clearly explained on the website or in any places, just use our question system or forum, supportjava.com, where you can find a complete and fast answer on any concerns that you have. So I will remind that we have this promotion information on the website, and we will share materials and video from this webinar workshop to social media and YouTube and our website on the front page. So you always have ability to see updates. Please subscribe to our newsletter to get to stay on track in any news that happens in the company and all our events that we do for customers. Well, it seems we have no questions and or we answered on anything, right? That could be asked today. So if so, I should say, Matt, thank you very much for this workshop. And that was really great, and I think it was self-explanatory about the details and testing methodic that we use in measuring this distance. So I'm eager to see these materials on the website in any form that we can share. Thank you everyone who joined this webinar today. We will continue our webinars. So please be updated on the website. Okay, I should say thank you everyone and have a great day.